Okay, so the last section is 1.7. Sorry, I have the textbook over here. And it's derived units. Okay. It's the use of base units, which was the last section, of grams, meters, that type thing. And then you do some mathematical function to them. You can square them. You can cube them. You can take two different ones like grams and volume or milliliters and get density. So a derived unit is basically a base unit that you then do some mathematical function, multiplication, division, squaring, that type of thing, to get a new unit. Okay, so if I square it, I get meters squared. Here's another one of division. If I take the distance or length divided by time, I get speed. Volume is a derived one, okay, coming from the length cubed, meters cubed. However, we typically will also use liters and milliliters. 1 liter is 1 decimeter cubed, and 1 milliliter is 1 centimeter cubed. For those of you who are in the Vet Tech program, you'll often see cc's when you're doing shots, injections, that type of thing. A cc is a cubic centimeter, so it's the same thing as centimeters cubed or milliliter. So if you have a syringe and you're supposed to give 0.5 cc's, that's 0.5 milliliters. It's a one-to-one thing. Density is the one we're going to spend the most time on. Density is a property of a material. So a density is something that can be used to identify what a material is. It's mass per unit of volume. So here's the formula. Density is equal to mass divided by volume. And you can actually stack liquids by having different densities. Some of you will have already done this lab. Others will be doing this lab this week. The most dense will always go to the bottom of the container. So this is showing mercury and copper. Copper is less dense than mercury, so it will actually float on top of the mercury, even though it's a liquid and a solid. Here's 3 different layers. Okay, this is orthoxylene, this is water, and this is a 1,1-trichloroethane. So these 2 layers here are organic solvents and not soluble in water, or not miscible in water, and so the water then separates them. Now, I'm going to spend the majority of the time doing problems. There's going to be 3 problems that we're going to do with this section, and they all have to do with density. So, I stated before, or I haven't maybe stated before, I've made these videos out of order. The strategy for doing word problems is the fact that you have to identify the important parts of the question, which is usually going to be the number, along with its unit, and then also you have to know where you're going. What are you trying to calculate? So here I've highlighted 30 milliliters in blue, and milliliters is a unit of volume. I've highlighted 23.6 grams in red. Grams is a unit of mass. I don't use M for mass simply because there are several M's that we're going to be using this semester. And then the question is, what is the density? So density is what? And the units for density are grams per milliliter, which could also be in grams per centimeter cubed. Milliliter, centimeter cubed mean the same thing. So again, I'm going to start out with the equation that I gave you on the other sheet. This equation is given to you on the formula sheet for the test, okay, where this is mass and this is volume. Since I want to solve for density, I don't have to do anything to this equation other than put the numbers in. So I have 23.6 grams and 30 milliliters, so 23.6 divided by 30 milliliters gives me a density of 0.787 grams per milliliter. Okay, so typically I don't count off for significant figures, but most of the time what I'm looking for in significant figures is 3 significant figures. So this one's not significant, so the 3 significant figures are those. Okay. Next problem, which is 1.78. It asks, what is the mass? So this is what I'm trying to get to. Of a 43.8 milliliter. Milliliter is volume, and has a density of 0.7 grams per milliliter. So I didn't quite do these in order. Volume is the 43.8, density is 0.70 grams per milliliter, and the mass is what I'm trying to solve for, and the mass is usually in units of grams. So again, I start with my equation, but this time I'm not solving for density, I'm solving for mass. So a lot of times I will actually draw a circle around what it is I'm interested in, because that will help me keep it straight in changing the equation around. Okay, as I said in the last video, the fact that this is mass divided by volume. But if I want to isolate the mass, I need to do the opposite mathematical function. So the opposite of division is what? Multiplication. So I'll multiply both sides by volume. So I get density times volume is equal to mass. And mass is what I want to solve for, so I'm just going to plug now my numbers into this equation. So density was 0.70 grams. And that's in the bad spot again. 0.70 grams times the 43.8 milliliters is going to be equal to the mass. My milliliters will cancel out, leaving me the grams. And so the answer that I get, it's thinking. I hate things that think this hard. Maybe it's not going to do it. It is 30.7 grams. Okay. So these two are not too difficult because this one I was solving for what the equation's already set up for, and this one, what I'm solving for was at the top of the equation. I just had to get rid of the fraction by multiplying both sides. The last one is 1.80. Okay. And the screen is just in a bad spot, not where I put it. So you get to watch it go across the screen. Alright, bromine is a red-brown liquid with a density of 3.10 grams per milliliter. A sample of bromine weighing 88.5 grams occupies what volume? Again, I've highlighted them in red. They're not in red in the textbook. Density has 3.1, so why is it not doing it? There it goes. Density is 3.10 grams. A mass is 88.5 grams. And what I'm looking for is volume, and typically the volume is in milliliters. Again, starting with the original equation, D is equal to M over V, but this time I'm solving for my volume. Okay? So when I'm solving for something and it's the denominator or the bottom part of the fraction, I've got to get rid of the fraction first. So the first step is the same as what I did the last time, which is to multiply both sides by volume. So I get density times volume is equal to mass. But again, I want to isolate my volume. So since this is density times volume, what's the opposite of multiplication? It is division. So the volume is the mass divided by the density. Now, some of you have the triangle where you have the upper quadrant's mass, the lower right is volume, and the lower left is density, and that tells you basically that if I want the volume, it's the mass divided by the density, or the density is mass divided by volume, or mass is the volume times the density. If you're used to using that triangle, you know where everything goes in that triangle and want to use it, that's fine. This right here is what I give you on the test, however. So what I'm going to do is teach you how to use this and do mathematical equations, no matter what the mathematical equation is, to solve for any of the variables. Okay. So since I have what I'm looking for, volume by itself, I now plug in my numbers. My volume is the 88.5 grams divided by the 3.1 grams per milliliter, and I get a volume of 28.5 grams per milliliter. So that's the end of this section, and so thank you very much.